Alrighty, in this short video we're going to wrap up Chapter P, the prerequisites for pre-calc, with section P-7, the rectangular coordinate system. And before we start talking about that, let's think back to geometry. Here I have a triangle, and you might notice down here in the corner we have this going on. I hope you remember that means that's a right triangle. And we got the sides listed as A and B, and then we have the hypotenuse across from the right angle listed as side C. Do you remember a theorem that ties the sides and the hypotenuse of a right triangle together? Well, I hope you remember the Pythagorean theorem. A squared plus B squared equals C squared. And we're going to use the Pythagorean theorem to come up with the distance formula. Long ago, geometry was pure geometry. There were not a lot of numbers involved with geometry. But then somebody took geometry and they infused it with the rectangular coordinate system, and they brought geometry and algebra together for analytic geometry. And that's where this stems from. Let's say here, this is our x and y axes, and this is our coordinate plane, and we're just going to look here in the first quadrant to keep this easy. Let's say we have 2 points. This would be point 1, and maybe up here is point 2. And we want to find the distance between those points. So we're going to connect these with a line, and we want to find the length of that line. Let's see here, this P1, here we plugged in coordinate x1, and we went up to the function and mapped over to the y-axis, and this would be y sub 1. So this point, P1 here is x sub 1 comma y sub 1. I don't like the look of that y. X sub 1, y sub 1. And then here's point 2. Here is our x sub 2. That gets up to the function. That's mapped over to the y-axis. This would be our y sub 2. So this point is x sub 2 comma y sub 2. And we want to find the distance between those points. Well, long ago somebody figured out, if I extend this side straight down, and I extend this side straight over, I've just created a right triangle. And we want to look at the length of this side right here. Well, the length of this bottom side of the triangle is the distance between x1 and x2. And of course, x2 is bigger, it's farther right on the x-axis. So the length of this side of the triangle would be x sub 2 minus x sub 1. We would just subtract this point and this point, and that would be the length of this side of the triangle. And then for this side of the triangle here, if we look over to the y-axis, our point P2 is up here, our point P1 is down here, and if we subtract those, y2 minus y1, we get their distance between these on the y-axis, and that is also the length of this side of the triangle. So here this side is x2 minus x1, and this side is y2 minus y sub 1. So if we use our Pythagorean theorem now, let me need a little room down here, get rid of that. We have Pythagorean theorem says a squared plus b squared equals c squared. Of course the hypotenuse is c, and it doesn't matter which of these are a and b, because they're sort of interchangeable. So let's plug some of these side lengths on our triangle up here. I'll do these in blue first. Here's this side of the triangle. We'll call this side A. And we know the length of that is x2 minus x1. So we're going to plug that in for this A. x2 minus x sub 1 quantity squared plus. The next side is B. We can call this our side B. And this side is y2 minus y1. So that B we're going to replace with y sub 2 minus y sub 1 quantity squared. That is equal to c squared, the hypotenuse squared. And we don't want the hypotenuse squared. We want to know the length between P1 and P2, or just c by itself, not c squared. So we would square root each side. When I square root the right side, it would just take out the square. When I square root this side, careful now, these are differences in the parentheses and we're summing them together. We can't take the square root of them because it's two things being added together. So we'll just leave it under this radical. So we have the square root of quantity x2 minus x1 squared plus y2 minus y1 quantity squared, and that's all under the radical. And that should ring a bell. You saw that in Algebra 1 and definitely Algebra 2 and again in geometry. So this is the 4th time you should have seen it. And that is our distance formula. The distance d between 2 points, x1, y1, and x2, y2, the distance between them in the plane is given by this, what we just found. That big radical, the difference of x's squared plus the difference of the y's, also quantity squared. All right, let's use that distance formula. In example 3, find the distance between these points, negative 2, 1, and 3, 4. And here is our distance formula. So we have our d equals, I'll make my radical. And then in the first set of parentheses will be the difference of my x's quantity squared. And I'm going to just look here, my x's I'll underline in red, and I'm going to subtract them from left to right. You could go right to left as long as you do it consistently with the y's. So I'm going to subtract in this direction, negative 2 minus 3. And that's quantity squared. Plus, then we're going to have our y-coordinates subtracted, quantity squared. So now the y-coordinates, I'll underline in black here, we got a 1 and a 4, and I'm going to subtract in the same direction. 1 minus 4. Okay, now we just work under the radical. Negative 2 minus 3, minusing is like adding the opposite, so that's going to be a negative 5, quantity squared, plus 1 minus 4 takes us to negative 3, quantity squared. And if we square those, negative 5 squared is 25, plus negative 3 squared is positive 9, and we add those together and get the square root of 34. We could punch that in a calculator and get a decimal. It's going to be a non-repeating, it's an irrational number. So the more precise answer is left under the radical, square root of 34. So that's the distance between 2 points in the plane. We also have the midpoint formula. If I want to find the midpoint of a line segment that joins 2 points in the coordinate plane, you can simply find the average values of the respective coordinates of those two endpoints using the midpoint formula. And here it is in the blue box. The midpoint of the segment joining the points x1, y1, and x2, y2 is given by the midpoint formula. Now, remember here, our answer here is going to be a point. We have our left point, we have our right point. This is going to be the midpoint. So our answer is going to be a point, an x, comma, y, our x coordinate and our y coordinate. And to find the x coordinate, we just add the two x's that we have, x1 and x2, we add them up and divide by 2. And then there's a comma there. For the y coordinate, we add the y values together, y1 plus y2, and again divide by 2. So example 5, find the line segment's midpoint. Find the midpoint of the segment joined by these two endpoints. And we'll call this x1, y1. And we'll call this other one x2, y2. Again, it doesn't matter what order you assign them in, as long as you do this consistently. So here, we're going to have our answer is a midpoint with a comma in there. It's going to be an x coordinate, comma, y coordinate. And our x coordinate is, we add the two x values we were given together and divide by 2. So here we have our negative 5 plus 9. Negative 5 plus 9. And then our y values. We're going to have our y values added together and divided by 2. And our y values are negative 3 and a positive 3. So negative 3 plus 3. All right, let's see what happens here. Negative 5 plus 9 is 4 over 2. And then negative 3 plus 3 is 0 over 2. And now those are going to be nice numbers when we do divide. 4 divided by 2 is 2. 0 divided by anything is 0. So there is the midpoint of our segment that would connect these 2 points. If we plotted those in the plane and we connected them with the line segment, the midpoint would be exactly at 2, 0. Here's just like a little application of the distance formula. A football quarterback throws a pass from the 28-yard line, 40 yards to the side, or 40 yards from the sideline. The pass is caught by a wide receiver on the 5-yard line, 20 yards from the same sideline. And what they gave us here are some coordinates. So here is 20, 5. That's our point. Here is the sideline and the distance in yards. So it says the quarterback throws a pass 28-yard line, 40 yards from the sideline. So we're 40 yards from this sideline, and the pass went 28 yards. or from the 28-yard line. So that is one of our points, 40, 28. The pass is caught by a receiver on the 5-yard line, 20 yards from the same sideline. So 5-yard line, 20 yards from the same sideline. There is our other point, 20, 5. So can you find the length of the pass by finding the distance between those points? You know, for that the quarterback stats, he passed from the 28-yard line to the 5. So in the stat book, he passed for to be 23 net yards. But that's, you know, just straight. The actual length of the pass was longer because, you know, it was on that angle that he threw the ball at. So we'll find the actual length of that pass. So here's our 2 points. I'm just going to write them together right here. 40, 28 and 20, 5. So we want to apply the distance formula. We're going to have our radical. Move that up a bit. And under the radical, we're going to have our x's subtracted and squared plus our y values subtracted and squared. So x's, I'm going to subtract left to right. 40 minus 20 goes in for my x's. 40 minus 20. And for the y values, 28 minus 5. And again, I have these under a radical. 40 minus 20 is 20 squared, plus 28 minus 5 is 23 squared. So when I square those, 20 squared is 400, plus 23 squared is 529. If we add those together, we get the square root of 929. And, you know, that number, we don't know much about it. This would be better understood as a decimal. So if we punch that in the calculator and hit the square root button, you know, we're going to round off a little bit, so I'll use the approximate sign. Approximately 30.5 yards. Again, the ball went forward, you know, 23 yards. But because we threw it here, this was like throwing along the hypotenuse of a triangle. You know, that length the ball actually went through the air was 30.5 yards. All right, I think that wraps up this section in Chapter P. A couple problems for practice. Team huddle, plot the points, find the distance between them, and find the midpoint. Let's not even worry about plotting them. Just find the distance between them and the midpoint. And then we'll do another one too, a mastery one, plot the points, or let's not worry about plotting. Find the distance between them and the midpoint joining them. So pause the video and try out this problem and then come back and see how you did. Okay, first it wants us to find the distance. B is the distance formula. And I'm going to have my radical, x's subtracted and squared, plus y's subtracted and squared. And it looks like this one, I'm going to subtract this one right to left. So 9 minus 1 goes in the first set of parentheses. And then 7 minus 1 goes in the second set of parentheses. So that is the square root of 9 minus 1 is 8. 8 squared is 64. Plus 7 minus 1 is 6. 6 squared is 36. And if I add those together, I get the square root of 100. And 100 is a perfect square, 10. And let's find the midpoint. Remember, when we find the midpoint, our answer will be a point in the coordinate plane. So now we add. We're going to take these same numbers I put up here in the parentheses, add them and divide by 2. So we're going to have a 9 plus 1 divided by 2, and a 7 plus 1 divided by 2. So the midpoint of that segment, 9 plus 1 is 10, 10 divided by 2 is 5, 7 plus 1 is 8, 8 divided by 2 is 4. 5, 4 is our midpoint, and 10 was our distance, D. And this is just another one here for a little more practice. Now we're going to do the same thing, distance between them and the midpoint. So here our points are 2, 10 and 10, 2. So our distance formula, x's subtracted and squared, added to our y's subtracted and squared. Let's go left to right again. X minus x will be 2 minus 10. And y minus y will be 10 minus 2. So here, 2 minus 10 is negative 8, and negative 8 squared is positive 64. And then 10 minus 2 is positive 8. Positive 8 squared is another 64. So we add those together, and we get the square root of 128, which is approximately 11.3. And for the midpoint formula, instead of, in here we subtracted and squared, now we're going to add them and divide by 2. Add our x's, divide by 2. Add our y's, divide by 2. So 2 plus 10 is 12, divided by 2 is 6. 10 plus 2 is also 12, divided by 2 is 6 again. There's our midpoint, 6, 6. Alrighty, the assignment for this section, very similar to what we just did. These 5 problems on page 66. That will wrap up Chapter P, so we're going to have an upcoming test on those last 3 sections. I believe it was P4, P5, and P7, as we skipped P6.